Hi students. So we had the introduction about the lab in the last class, and we have seen the first experiment also we have finished. So now we move to the second experiment. So what was the second experiment? It is measurement of current, power and power factor. So this circuit we work with the AC circuit, 230 volt AC. So power in an AC circuit, you will be remembering single phase AC circuit power is VI cos phi, where V and I are the RMS value of voltage and current, and cos phi is known as the power factor. So that so we will be finding out current passing through a lamp, the power taken by the lamp and the power factor of the lamp. So the objective is to measure current, power and power factor of incandescent lamp, fluorescent lamp and LED lamp. So by doing this experiment, you will get an idea about out of these three lamps which is better, which is the best to use at the domestic purposes. So what all you require, apparatus or things required are, we need one of each lamps, and we need a VAW meter. VAW meter corresponds to a meter which can measure at the same time voltage, current passing through it as well as the power taken by it. So we make use of a VAW meter to measure the current, voltage as well as the power taken by the lamp, and of course we use connecting wires. So now coming to the theory, you may be knowing about what is an incandescent lamp, the bulb we used to have at our domestic purposes earlier. Nowadays most of us are using a combination. In some rooms, in some places you may have an incandescent lamp which is the round bulb, and whereas the fluorescent lamp means it is the tube light, which you normally call it as a tube light. And then the other new bulb which has come up right now is light emitting diode. So it is again LED, we call it as an LED. We have LED lamps also. So the incandescent lamp, how it works, you know that there is a filament inside the glass covering, there is a filament inside, and the filament is made up of tungsten. The filament is made up of tungsten. So this lamp works by incandescence. So now what is incandescence? It is the emission of light when the filament is heated up. So when the tungsten filament heated up, it produces light. So that we call it as incandescence, and we convert electrical energy into light energy. So how the filament is getting heated up? It is getting heated up by the application of electricity, or say we connect it to we switch on the light, means 230 volt AC is applied to the bulb, then the filament, because we know that current has heating effect. When current passes through a conducting material, it gets heated. So that heating creates or produces light. So that is incandescent lamp. Now what is a fluorescent lamp then? Fluorescent lamp is the tube light. So how do that work? It works upon fluorescence, or fluorescent lamp work by ionizing mercury vapor inside the glass tube. Now how the mercury vapor is ionized? That is ionized when you apply a high voltage across the electrodes of the tube. So from where you get that high voltage to ionize the mercury, so that is why we use, you might have seen we have a chalk as well as a starter. We make use of a chalk, a box shaped thing, that is we call it as a chalk, and starter. So these two things, by making use, chalk is nothing but a coil. So coil, yesterday we have seen, it has inductance property, we discussed. So because of the inductance property, the magnetic effect, it can induce high voltage across the electrodes by using the starter. So that high voltage will vaporize the mercury inside the glass tube. So mercury gets ionized. So and then then it emits photons. So it emits photons, and that photons are having UV frequency, means ultraviolet frequency. Now then, how the ultraviolet frequency is converted into visible light? We have to, that is done by the phosphor coating inside the glass tube. So UV light is converted into visible light using the phosphor coating which is inside a tube light. Now the third type bulbs which are nowadays coming up is light emitting diode. So this actually is a solid state device, means it is basically a PN junction. So when a PN junction is forward biased, what happens? We know that at the junction of the PN junction, electrons and holes, they meet and they recombine. So when they recombine, what happens? The energy Eg, the forbidden gap energy, when the electrons fall from the conduction band to valence band, what happens? The energy is liberated. So that energy is liberated as photon, which produces light. But of course it won't happen in silicon, germanium and all, but we have to use typical materials such as gallium, arsenic, etc. to get this particular light produced. So that is the working principle of an LED. Now we will have a comparison of the different ratings of these lamps. So here you can see this is the incandescent bulb, which we call it as, say, for a wattage of 60. Whereas CFL, what is CFL? It is compact fluorescent lamp, compact, so small size. So it is having only wattage, see, 18, means the power required is less to light a fluorescent lamp. Whereas coming to LED, again it is less, it is only 10. So lumens, which if you compare, it is almost the same. Then life means what is the lifespan of the bulb which you can use. So here it is in years, it is written, so it is almost an year, whereas CFL you can use almost 9 years, and whereas coming to LED you can use it over more than 20 years. So the life of a LED is much better compared to the incandescent lamp. Of course cost also is shown there, and this is the kit which we use. Kit means it is already assembled, you don't have to connect much wires to it, and it is having our protection in it. So that is the kit which we use for doing the experiment. And this is the diagram, the connection diagram of the particular kit. So this is the AC source, the symbol is this, and this is 230 volt 50 hertz supply. L stands for live or line, and N stands for the neutral, and we have an MCB here. MCB, I told you yesterday, miniature circuit breaker. It's a safety device which we use, and through the MCB we connect the 230 volt to the bulb, and we connect an ammeter. In this 3 readings are given by the VAW meter. So it's an ammeter which will be connected in series with the load. Load means the lamp. The lamp, we call it as the load, which takes the current from the voltage. So, and we have a watt meter. This is a symbol of a watt meter which measures the power. So it has 2 coils inside it, and then this is the voltmeter, which always is connected in across or parallel to the load. So ammeter is connected in series, wattmeter is connected in series, whereas the voltmeter is connected across or parallel to the load. So this is the procedure, like make the circuit connection as per the diagram, then fix the lamps in the corresponding holders. So this is the lamp holder is this here we can change by using a switch, we can change the lamps, then switch on the power supply, note down the voltage, current and wattmeter readings, calculated the PF and verify the tabulation. So how do we, power factor is nothing but cos phi, power factor. It is the cos of the angle between the voltage and current in a particular load. So cosine of the angle. So how do we do that? Because I told you the power AC power equation for a single phase AC, the power equals VI cos phi. So this cos phi, this term is known as the power factor. So to get the power factor, what we should do, we measure the power by the wattmeter, we know the voltage, we know the current. So what we require is cos phi. So cos phi equals P divided by V into I. So that is what is shown in the diagram in the tabular column. This is the lamp type we write, serial number, lamp type, incandescent, fluorescent and LED we do. VRMS we write, VRMS is the RMS value of the voltage which the voltmeter measures. IRMS is the RMS value of the current, root mean square value of the current which the ammeter measures, and W is the power in watts. So to get the PF, which is the power factor, W, which is the power, divide, I have written it as P and W both are one and the same. Watt, the power, as it is measured in watts, it is sometimes referred as W. So W divided by V into I. So that is what is written here. So V and I are the RMS values. So that is how you calculate the power factor, by measuring the power, voltage and current. So these are the post lab questions, so that I'll just read out for you. The filament in a lamp is made up of, we discussed it, tungsten. Mention the types of lamps, what is meant by CFL, compact, fluorescent lamp, what are the advantages of CFL. So we have seen the advantages, it is having better life and the cost is less. And then what is meant by LED, light emitting diode, how do it work, we discussed its operation. What define power factor. Power factor can be defined in many ways. One way is, as I told you, cosine of the angle between voltage and current, and second way of defining it is a ratio of R by Z, means resistance to impedance of a circuit. It's the ratio of resistance to impedance of a circuit. It can also be defined as the ratio of active power to apparent power. So that is another way of defining it. All these are power factors. Then explain the working of an incandescent lamp, which we have discussed. What is the usual power factor of fluorescent lamp and incandescent lamp? It is nearly 1. When we do the experiment, you can see the values. So that is about the second experiment. Now we can do the experiment on the kit and tabulate the readings. Thank you. So students, now we will conduct the particular second experiment number 2, measurement of current, power and power factor of incandescent, fluorescent and LED. So I have showed you this is the connection diagram which we are going to use, wherein you have the line and neutral connection which is connected to a 230 volt AC supply through an MCB, and in the connection we need an ammeter, voltmeter and a wattmeter. So we will take down the values of IRMS, VRMS and power consumed, which is wattmeter reading of the lamp connected, from which we will calculate the power factor. We will calculate the power factor by dividing wattmeter reading with VRMS into IRMS. So that's all the calculation which you have to do. So let us use the kit for the connections. So this is the kit which I have showed you earlier. So this is the line and this is the neutral which is connected inside to the 230 volt supply there. So here you get, at these 2 points you get 230 volt 50 hertz supply. So we have to connect, all the meters are connected inbuilt in the kit. We just have to connect this wire, this is the line connection and this is the neutral connection to the meters. and then we need to connect the load. So load is nothing but the lamps. So this is the incandescent lamp, this is the fluorescent lamp, and this is the LED. So sorry, this is the LED and this is the incandescent lamp. So by using these switches we can connect any of the lamp at a time. So this connection is for the load. Load is nothing but the lamp. So now the connections are made. We can switch on the power supply. So the power is switched on there. Now we need to connect, this is the MCB. MCB we already discussed is the miniature circuit breaker or the safety device. So this is connected internally here. So we can switch the power on. So now you see the readings. This light shows the power is on. So current is 0, voltage is 240 or 242, and the wattmeter is also 0 because we have not connected any of the load to the circuit. Now we make use of the switch to turn on the incandescent lamp. So now internally this point is connected to the incandescent lamp. So you can see the current readings 0.119. So we can write a lamp type, serial number 1, lamp type incandescent lamp, and VRMS is 242 or 243 volts. This is in volts. IRMS is 0.119, and the wattmeter reading is 29.03 watts. 29.03, and this is in watts, this is in amps. So we can calculate W 29.03 divided by 243 into 0.119. So that will be the power factor here. Now we'll do the calculation later. We'll change the lamp here and take the readings. So we switch off this first. So now that lamp is disconnected from the circuit. Now we switch on this in which the CFL gets switched on. So which is the fluorescent lamp. So here we see the values are changed, current values are changed. So it takes earlier the voltage is 242, that's almost the same, 242.5. So this is for CFL, and IRMS is 0.090. And the wattage rating is 21.06, 21.06. That's a power consumed by the CFL. So now we move to the next lamp. So we switch off this. Now we can connect the LED. So LED, again the current is reduced much. So you have the current as 036. This is 243. So this is LED. And the power is 8.79. So from this reading you can easily make out the power consumed by the LED is the least in among the three. Incandescent lamp takes maximum power, the CFL is in between, and LED takes the least power. So we do the calculation now. So this is 29.03 divided by 0.11. So we have calculated the power factor of all the lamps. Now for just for your information, suppose if I connect two lamps together, what is going to happen? Let's see. See, now what you observe is the current is, as these two lamps are connected, the current increases. The current increases. Earlier you had only 0.199 and 0.090, but now you have 0.206. The current increase because both are taking the power from the 230 volt supply. So voltage remains same because they are connected in parallel, and the power, total power also changes. So in earlier we had 29 and 21, so it's almost 50. So that is what you are seeing here, 49.84. So by this what you can say is, as the voltage remains same, the internally these two bulbs are connected in parallel, so voltage remains the same, current gets added and the power gets added. So if I switch on the third light, what should happen? The current should increase further and the power, total power taken also will increase. So see, it is 0.244. So the current is added, all the earlier current gets added up, and the voltage remains same because it's parallel connection, and the power becomes increase. It is the totaling of all the individual power of the light. So that is what is all about the power and power factor measurement of lamps using the kit. Thank you.